at you. That was Mark.
If you don't want to do testing, I think he's hiring.
Yeah. Yes and yes. Okay, next up we've got Lyle Resnick from LifeTales. Looking at TDD Viper, so thank you very much.
Hey guys. Okay, so within about a year and a half ago, I got involved in TDD. Just before that, I got involved. Does anybody know what Viper is? Have you heard of that? Okay, so let me describe it to the rest of you. Viper is an attempt to decompose view controllers into smaller parts in trying to avoid the massive view controller problem, which is directly a result of the get into that. So I thought I'd throw that out. So part of what we're trying to do here is to make it so there's less code in the view controllers. Viper helps us do that. TDD, as you already know, is about test-driven development. And I found that when we put them together, they were actually marriage, which is quite nice. So, you've actually heard this tonight already. This is a major rule of thumb of test-driven development. You either test you have two things to test. You either have to test outputs, the other side of the inputs, or the side effects of a method, but not both at the same time. The output's captured by either a result or protocol. So a result is just a pure function. A protocol is used when you're passing data to another layer. We'll talk more about that later. Side effects are captured by properties of overridden methods. There's names for these kinds of things, stubs and mocks. Frankly, every time I read the difference, I still can't figure it out. So don't even ask. But you'll see what I mean later. All right. So what does Viper provide in terms of test-directed development? Scenes, protocols, and a plan. Okay, so scenes provide a place to insert tests into the code. They're places between method calls. Protocols provide places to send the output between the stages. And the plan is something we already know because we're dealing with Viper and the whole team knows that. So I find that Viper provides some of the things that we inherently do. So I'm going to give you a quick overview of Viper. I don't expect you guys to get the whole thing all at once. I have 45 minutes, so we'll see what we can do with it. So your basic Viper classes are like this. You have a view controller. There's a piece called the presenter, a piece called the interactor, the router, and an entity gateway. It turns out that this is showing ownership, so that means I can know about the interfaces to these from the ones that perceive them. But I cannot know about the interfaces going in this direction. And that is part of what makes it so powerful. The entity gateway is a pure interface. So what's happening in these things? The view controller deals only with the events that are coming in from the keyboard, mouse, and everywhere else. And it also only deals with views. And that's kind of what you'd expect it to deal with until you start actually writing a lot of code. The presenter deals with what we call the presentation level, where data is converted from input. Data is converted into the type of data that's needed for viewing. The interactor is where all the action happens. So all of your algorithms end up inside the interactor, and they deal with entities that come from the entity gateway. The entity gateway is injected into the interactor. So actually, you don't even know where this data is coming from, and neither should you. So it turns out that data flows along this way, and when you get to here, you actually have a protocol. When data is flowing out this way, you also have protocols. So what happens is a request comes in. Actually, I haven't talked about the router yet. The request comes in, gets passed to the interactor. The interactor calls out to the outside world through some devices. It could be devices, it could be location data, it could be anything. Comes in here, gets interpreted, and then gets converted. So everything in here is pure. It gets converted to external here and goes out to the view controller. So there's natural places where these scenes occur. Protocols are here and protocols are here. I'm not going to talk a lot about the router today, but the job of the presenter at the inbound level is to figure out whether something is going to the interactor or to the router. The router is the guy who takes care of switching view controllers. That's what the router's for, same as a router in a website.
Just the way you were talking about ownership or knowing between the different layers, there's no icon, there's no graphic on those, do they know about each other? Is that bidirectional?
No, the view controller only, I'm trying to show ownership here.
Yeah.
So the view controller knows the presenter exists.
Sorry, I didn't clarify. Between the presenter and the router.
Yes, sorry. This is left. Yes, you're right. Sorry. This guy does not own this guy. I actually should have put ownership here. Actually, sorry about that. This is in flux. It used to be the other way around. I'm going to do another chapter on that subject. Good question. It does turn out the router owns. Sorry. No. Okay. It's definitely in flux. Okay. No, this guy has a reference to this guy. Yeah, you should be. This guy's bad. This guy should be able to. I'm not going to go there today.
Okay.
Okay, and I'm purposely not going to go there. Okay. Okay, so what I want to show next is an augmentation of the Viper classes, which I found through an understanding of TDD and also using a few other people's ideas. In particular, that is the separation of any table adapters from the actual code. Don't forget, in Viper, we're trying to reduce the amount of code that's inside the view controller. So basically, any back pointing through through data sources and delegates is basically a no-no, especially in trying to reduce the code. So we turn the table adapter into an object itself. The table adapter also knows about the presenter. And there's another case here for the interactor. I've introduced something else called a transformer because the interactor gets really large. So transformers, so you can think of it as anything that happens in the view controller. So every event, every button press, you select a record, you do a view did load, any kind of event that could occur in the view controller has an analogy in the transformer. And likewise, there's going to be a protocol going in this direction for every single event that comes through. So there's going to be a protocol called an output protocol for the interactor, and there's an output protocol for the presenter. These protocols make it so that we can do TDD really easily.
Sorry to be that guy.
Go ahead.
How does a table adapter differ from a data source object?
It is one.
Oh, it is one.
It is one.
So you could otherwise just call that a data source.
It absolutely is. Absolutely, but it's both. Yeah. So I call it. Actually, the word comes from Android.
Oh, okay.
That's
so
what
it's
they call them.
It's mapping another.
It's exactly the same.
I understand. Because I'm just trying to figure out where it's like instead of having a monolithic view controller, you have your data sources and delegates that are their own objects themselves, and you can create them somewhere else and pass them along and inject them all the way down the chain, and they all contain that information. Yes. So that represents the same type of thing, just with a different label.
Yeah.
Got it.
Yes.
Sorry.
Yeah. So they just input it too. Yeah. So actually, part of what we're trying to do with TDD is make more and more objects that do smaller and smaller specific things. So, and it actually gets really neat. I've had an experience just talking about the adapter for a minute where I've actually been able to use the same tables and you switch the adapter and all of a sudden you've got something else going. It's quite nice. It's a good example would be searching for something. You've got 4 different choices, and you can have 4 different adapters related to those choices. Just pick the one. So it's a kind of a nice technique in itself. Okay, so now we're going to talk about, I'm going to look at the same thing from the point of view of interaction. So here we have the user, he touches something. View controller receives the event by way of usual event mechanism, and we send that event over to the presenter, and presenter does nothing more than send the same event over to the interactor. By the way, I might use the word use case. Some people call the interactor that. Okay, so actually nothing much is happening here. Okay, all that's happening is parameters are being passed along, and potentially the presenter could send its message to a router. So that's why it looks really boring at this level. Okay, all the action happens here. Okay, so basically the interactor receives the fact that something's required and sends a request out to the entity gateway. What is the entity gateway? It leads to your service layer. So if we're all familiar with service layers, the nice thing about the entity gateway is that it's injected into every single interactor, and it has access to whatever services. It literally just has references to every single service. You pull that service into the interactor, and that's how you make the request to the gateway. Okay, then you get your response, and it's usually asynchronous these days. And then what happens is you present X given result Y. So you may have a number of functions on this. This is a protocol. You may have a number of functions, so you could have like 10 different functions that get called just because of event X. And actually, we're going to see that later today. You can think in terms of printing report, because that's where we're going to go. Then what happens is the presenter receives result Y and converts, oh sorry, I forgot to say, everything that happens in here is pure converted data. You're not doing, so basically the entity gateway does all your data conversions for you. You're assuming that all your Java, all your JSON is actually converted into the most useful primitive types. So dates are dates, floats are floats, and enums are enums, because if you're dealing with enumerated types, you may as well turn them into enums. They're easier to deal with. So you deal with all of your data without reference to having to do any kind of conversions, because they just get in the way. The data, you already know by the time you got your response back whether your data is good, because your service layer dealt. Okay? So then finally, it's time to convert the data, and in the presenter, you convert it into its most useful form. So usually it's going to be strings. Sometimes it's going to be dates if you're putting it into a date tumbler or whatever you're doing. And you do your localization, internationalization here as well. So you have a place to do it. Then finally, when you get to your view controller, you show that's where show comes in. You're showing given event X, whatever the result Y, whatever your result is. You're converting it into, that's where the conversion's done. You finally see it. So this guy takes the converted data, conversion's done. This guy takes the converted data and sticks it into the views that you expect to put it into. So I'm going to make that a little more concrete. But as you can see, there's a ton of seams all over the place, every single point here. They're all pre-known. I mentioned the back hours of protocols, and we always do it the same way. So every single person on the team is doing this the same over and over, and we all know where to find stuff. There's quite a few rules. One of the rules is that you don't do any work in the view controller that has to do with any business logic. So that's why we send the events on immediately. I was looking actually at a view controller today that had been done properly that way, and we still had 300 lines of code configuring views. Okay, so view controllers get big. If we actually put all the code in the view controller, not including the service layer, we probably would have had 1,000 lines of code. So it's worthwhile.
I might have missed. What does the interactor do again? Because I get the presenter like converse.
Yeah, the interactor does everything that's the business.
on a previous slide, you also had another layer of that, which was a
Yeah, the transformer.
transformer.
Okay, so what happens
How does that
here? Yeah, so what I found in my work is that if I split, the interactor gets really big. So let's take a situation where
Just the problem you were trying to solve was big
big
view
interactors.
controllers, which
Now-
now you've just, through a couple levels of
Yes.
interaction, moved over to this
Yes.
interactor thing that you know how
Yes,
to define.
yes.
You haven't really solved the problem, you've just shuffled it
No,
down
but I am.
through a couple,
You haven't been
as I read this, you've shuffled it down through a couple layers of indirection without any type of information
Yes.
or
Nothing has
encapsulation.
changed here.
So you're just,
Nothing
so
has
why
changed.
not just put it locally in the same spot?
Because it's a lot of stuff.
Hear about the transfer.
Yeah. Okay, so
Now you're scattered.
realize that for every single event that comes in your view controller, you're going to end up writing a pilot. So you can put all that code in one place, and then you can go look at it in 3 months and go, what the hell? Here, which we usually do. Or you can put it in a place that exists, so it's got its own class. So an example is, actually we'll see an example later where there's a transformer that actually has a reusable function in it. And that reusable function is very much only for that specific case. By putting it in its own class, this is basic stuff, guys. You put something in its own class so that you limit scope. And that's what the transformers do. It's very simple. We'll get there, though.
Do you find that there is a risk of bloating your project as a result of this many classes?
No, the code level is the same. The boundaries are, okay, so there is code for boundaries, because that's what we're creating, code to encapsulate. I love that stuff.
So just
Personally, just
wait,
Okay, you go.
just to go back to the young man's question about what exactly is the interactor doing. Give an example. Like,
Oh, yeah, so if
like
I...
so an event, like somebody taps on a table view cell. Go.
Yes, so guy taps on a table view cell and you have to respond to that. So let's say, well, that's actually not a good one because that might lead to a router.
Got it.
Okay, so that's pretty much going to lead to a router. A better one would just be a view did load. Okay, a view did load causes you, besides configuring views, or what's left of views, you tend to do some things like go out to the internet and grab some data, and then you have to display the data. So what's happening here is you do the request, okay, it goes out to the gateway, it comes back. Basically, you take that data. Remember that when it's coming from the entity gateway, it's already formatted. The JSON is long gone. You're now dealing with entities, okay, which are either structs or classes at this point. And then your next job is to, actually in the first case, if you're just pulling in a table view data, you're probably not going to do that much. Maybe it's just a sequence of repetitive records. So basically your next job is to get them over to the presenter so it can be formatted and then out to the cells. So that's the kind of thing that goes on. Everything you normally do when you're talking to the internet, as an example.
You also said that usually, like the changing of the screen happens in the interactor, right? But you also-
You mean navigation?
Yeah.
Yeah, that happens in a router. That's why I didn't pick up on the press the button to the guy clicks on the cell. A better one would be clicking on a button.
Well, the reason I asked this is because before that you also mentioned that sometimes you talk to the router from the presenter.
Yes.
How do you
Yes.
define like where do you?
So the rule of thumb is that all events go to the presenter. That relieves the view controller of having to deal with anything but views. It has to make no decision whatsoever. And that rule is really a good rule,
It's kind of like sort of reactive.
I guess. I think it was passing the buck. It's just get it over there. I don't want to deal with it. Okay, so then the presenter will talk to the router, and then it'll figure out who's next.
No, what I mean is, how do you define when you need to talk to the router
Oh, that's
from
up-
the presenter
that's
or the
totally-
interactor?
That's totally up to what you need to do with the same way you would determine it if you weren't using Viper.
The typical thing, and the reason why the table view cell is a bad example is because usually if you tap a table view, so you're going to get a detail view, so that would be a separate view controller. So you would invoke the router at that point to present the separate view controller details, right? So
Yeah,
so
whenever
you're going to stay within the view controller, you're going to talk with just the interactor at the end of the gateway, right? But if you're going to be going to another view controller, present controller, you're most likely going to be routing that through the router.
Okay.
The navigation controller is a router
Yes,
sometimes.
yeah, it should be. The latest history is it should be.
I spent 6 months.
Yeah. Anyway, okay, so any other questions at this point? Yeah.
Oh yes. So the name Viper, does it have anything to do with the fact that this diagram looks like a side?
No. I don't know if you're being funny, but you are. VIPE, the router. Good try though. Anyway. Okay, so let's see this stuff in action. Okay, so we're going to take a look at a Viper, basically a view controller that hosts this kind of view. Okay, you basically have it's a credit card transaction thing. I don't know who works for a bank here. You've probably seen it before. You've actually seen it every month if you don't work for a bank. So you've got your authorized transactions and your posted transactions. You group it by date. And there's two groups. They're identical, and then there's a grand total. There's a total at the end of each one of the sections. So that's what we're trying to produce. Okay, and we're going to do it using TDD and Viper. Hopefully. Okay. So the first thing about Viper is that we already know what the classes are. Okay, at least the main classes. That just like you guys know the classes in your toolkit every day, we know that there's going to be the 5 main classes. So we can either manually create them, or we can generate. Okay, there's an extra class called a connector as well, which actually puts all of these classes together and makes them know about each other. It sort of happens from outside. He's called a connector. But what I found in the end is that it's much easier to produce a template and generate. Okay. So that part's done for us, and that's actually easy. Okay, so now let's talk about TDD for a minute. Okay, I say where to start. I say start with the view, and I say it because we all love starting with the view. It's comfortable, and it gets us to know what we're dealing with. Okay, but the other interesting part of this is I'm also mentioning that you should start with the IB injection tests. And you're going to think that this is mundane when you see it. But it's actually quite freeing because once you do it, you go, now I never have to worry about making a spelling mistake. It's quite interesting. I'm also going to mention that you should try to create views for all the states. I'll talk more about that in a minute. What I mean by that, well, actually, I'll just go to the next slide. One thing I find about TDD, and sorry, you've already heard a little bit about this, so I'm not describing it specifically. You know that you write your test first, and then you write the code. Okay, well, because you're writing all these tests before you actually even run your main application, you actually can forget to run your application sometimes. That's happened to me. But that's also freeing because you're not so concerned about getting the good path done, golden path. The reason that we tend to think about the golden path is that, well, we've got golden data. We don't have failures happening all the time. We generally have live test beds that run. Okay, we don't have live test beds that don't run occasionally. And actually, we have to make them fail. So in order to test the code that we normally have to wait for to set up, and that we never get done because we always get the good stuff done because it makes our bosses happy, we can now be free to think about all paths. We can create the views for all the states that we're going to meet, including the failures, the singletons, or the singles. We have a lot of paths now in the project I'm working on now where there's no data. So what are we putting up when there's no data? We decide to put up graphics of certain types or instructions of what you're supposed to do next. We can test all this really easily because we just can. And you'll see that in a minute. So what I've done actually is mentioned, there's an article which I can send you. Actually, there's an article called The 9 States of Design. I recommend it for everybody. It lets you start to think about all the different things that can happen. It's quite a good article. Right, so I've listed those states. These are them here, and then there's one state called incorrect, and it can either be semantic or systemic errors. All right, so I recommend that you think about all of that. And I also think you should work on one event at a time, and we usually do. We deal with view did load, and then we deal with view did load. We press a button, we deal with the outcome of that button. So basically, on an event-by-event basis, think about the way your system is going to look at the end of that event. Okay. So let's take a look at the storyboard. And we're going to actually build this storyboard. I'm not going to go through every single tiny detail because we don't have time, but I can get you to understand the rhythm. So this is the storyboard I want to end up with. Okay, and it literally looks like the data that we looked at 2 minutes ago. And you can see that there's headers, subheaders, detail, subfooter, footer, brand footer, and message. Interesting to note the message. The message is actually representing the states where there's no data, or in this case, there may only be partial data. Because in this case, there are actually 2 inputs. There's an input from the posted transactions, which are all coming from the bank, and there's input coming from the credit card processor, which is the authorized transactions. You may not be able to, you may have none. There may be cases where you haven't used your credit card this month, but you're still going to pay for the ones from last month. So you actually have a null state where you have to put messages up instead of reports. So those are the kinds of states I'm talking about. Okay? So now we're going to talk about the injection tests. And these are going to be the simplest tests that you could literally run home and do them yourselves because they're really simple. So what are we doing here? Okay, so does everybody know what an SUT is? System under test. Think of it as class under test. So every set of tests has something we're testing. Some people call it a system. Some too. You're testing the methods within that system and testing the behavior of that system. So this is how it works. Just repeat. You create a failing test. You've heard this before. We're going to see that in a minute. You lay out your views in IB. We all know how to do that. Now, it's interesting what the failing test is here. We'll look at that in a minute. And associate your views with any classes they're going to use and any identifiers that you're going to use. And these are going to happen at different times. And then you create and connect the outlets, and then you run the test, and hopefully it passes. So let's take a look at the injection test. Get out of trouble with my cursor. Okay, so this is the very beginning. So what I do is, at the beginning, there's a setup here. I'm using...
Can you make it bigger, please?
Make it bigger.
Plus.
Yeah, it's really.
Or.
Okay. Right. Okay, so at the very beginning of your first test, you're not going to decide. Setup will actually be blank. You'll end up putting your stuff in your first test. And little by little, as you make tests for this SUT, you'll start moving things up into the setup. Basically, the setup runs it for every single test clean. So in this case, by the time I finished writing all these tests, I ended up with a setup that looks like this. And what we're literally doing is pulling pulling this class we're instantiating out of the view controller. And if you want, does anybody know what that is? Why I'm doing that?
Triggering muted load.
You got it.
There's a method to do that.
Yeah, it's called viewed
Load view needed.
if needed or something. Yeah, I know. But yeah, you can do it that way too. So, okay, and another thing that I'm doing is when I do okay, so I'm doing a little bit of what IB would do. Sorry. I'm testing this. I'm sorry. This is another piece that got pulled out from all the tests because it was injected. So what I found is that because your view controllers are coming from objects, from NS objects, you can use value for key or key value coding to grab all the values and still keep your stuff private, which is useful. Not so much in Swift when it's coming from Swift, when it's just a regular Swift object. Okay, so what are we doing here? Okay, so the first thing we want to do is test to make sure that the table view got injected. Okay, really simple stuff. And you heard before that you really shouldn't do more than one assert per method. Sometimes it gets really boring. So I don't follow that rule all the time. I would have to write 4 tests for these 4 different asserts. It's whatever. That gets the job done. Okay, so basically I'm inserting that the table view is not nil. The next thing I'm doing is finding out, I actually injected my adapter in this just because it felt like it. So I'm checking that the adapter got injected. Oh, I used the word injected. Somebody once referred to IB as the greatest dependency injector that he's ever seen. So I never forgot that because that's what it is. Then the next thing is the table view to see that it got tied up with the data sources. So how did I do this? The first thing I did was write that. Then I created a table view. Then I connected it. Then I ran the test. So that's the first line I wrote, other than those. Okay? So basically all that used to be in here, and then as soon as I started reusing it, I moved it out. Okay? So that's the first thing I wrote, and the test ran. The next thing I wrote is, okay, I also want to see if I got to create an adapter. So I wrote that line. I created an adapter over in IB, connected the outlets. And created the outlet for that matter. Connected it and ran it. It passed. Boom. Next, same thing with the table views. I wanted to make sure that I had my data source and delegate hooked up. So what did I do? I wrote these 2, or probably wrote 1 at a time. I connected it in IB. Everybody knows what I'm talking about, right? Okay. I ran them and we're done. Test pass.
Question. While developing, you would run your code. When would there be a case where this would not occur, or when, for example, your code goes through QA? When would any of these ever fail that requires these tests to exist that wouldn't cause in normal operating?
They'd fail when I somehow lose a connection, which has happened many times. Okay.
Someone tweaks the layout and they drop a connect.
Exactly. It happens all the time, and you're not going to find out until runtime.
Rename the class. Rename a view control class that has an ID hooked up to it.
Yeah. So things happen out there, and it's going to get more interesting in a second. Okay. And so what I'm doing is I'm using this to show you the cadence TDD, if you like. Okay, and yes, I know it's trivial, but I got to tell you, every time I do this, I give a sigh of relief that I never have to worry about it again. Okay, next up, cells. Okay, so my objective here is to make sure I can dequeue cells. Okay, and I don't know how many times this has happened where this stuff, accidentally, I type in a field I shouldn't be. Okay, so what did I do here? I knew originally that I was going to do this in this pattern, so I started one at a time. I added the header, so I took that this wasn't here originally. I said for cell ID and header, I then went, here's the test. I said I want to DQ the cell, and I want to assert that the cell is not nil. That's my test. I go over to IB. I create the cell. There's nothing in it at this point. There's nothing in the cell. And I create the class. There's nothing in it. And I do the same thing 6 times or 7 times to create my cells. Now I'm done. Now I will always have these cells. They will always be dequeuable, and I will never have a problem at runtime. Okay, then the next step. Okay, let's make sure that that IB injects all the outlets of any particular cell. So I'm not going to go through every single one of them, but this becomes a more pure test of only doing one thing. So here I'm going to DQ the cell with the header. I've already tested that I can do that. And I grab the title label from the title label property, and I make sure it's not nil. Great, IB injected it, test passed. Same thing for all the rest of the cells. As you can see, it gets rather boring. And here I did 2 of them because I've got 2 things in the cell. So this is the detail. So there's a description label and an amount. Same thing with the footer. There's a total. In the grand footer cell, it's got a total label. And that's about it. So that's how I did TDD to create to create a ID to do the view. Okay. Yes.
The boilerplateness of this makes me think that it would be really well suited to some sort of meta. So it's like
generator?
Yeah.
Sure. Go for it.
Like, because I mean,
Call me.
I don't know. Well, no, I don't know about you, but I know about me. I couldn't write that.
Also, if you use the DQ reusable cell with identifier and index path, the tests, maybe your injection tests are necessary, but your can't DQ test is no longer necessary.
Where are we, sorry?
If you scroll up where you have the array, if instead of using DQ reusable cell with identifier, right, which it returns a optional value, right? If you use DQ reusable cell with identifier and index path, that's a non-optional value, right? It's guaranteed to return a cell that's registered with the class, right? Or crash if not, right?
So I'm missing.
This test is not necessary.
Like you could,
Yeah.
You can still try to assert the identifier itself.
Yes.
Well, no, but if you set up your mock data or whatever such that like you have seven pieces of data, each one corresponding to this type of thing, like index 0 has header data, 1 has subheader, etc. Then if you pass in the index path for each one of them, right? So like use cell ID for each or something. You wouldn't need to do each one of these. It would pass or fill if it could create the cell based on the data and the cell ID.
Okay, so we test differently.
Right.
That's fine. Actually, you may have just answered a question for me. I had a failure on something where it couldn't map the rectangle, and it's probably because I didn't use what you just said. So anyway, that's the idea. We can tear it apart and make it better. That's no problem. All right. Next step. Cursor. Okay, so the next step, so the order that I'm going in is actually the opposite. I'm going to go in the opposite order that we normally program. And it's really weird because I'm going to go from the output to the input. Normally we go from the input to the output because it seems more intuitive. It also, we set it up that way because when we're testing without tests, when we're testing manually, you actually need to have your output to make something input to have something happen on the output. So it's natural to do it that way. But because I'm doing test-driven development, I actually don't care what I test first, which is really interesting. So what I'm going to test is moving the data from the presenter to the view controller first. So that's going to be next. Okay, so I start with the presenter output. Okay, so we haven't actually seen what the presenter output looks like yet, but we're going to see it in a minute. It's basically the presenter output is a protocol, and we're implementing the protocol. Okay, it's called by the presenter on the view controller. So these are actually functions. The view controller is implementing what the presenter tells it to output. Okay, so we instantiate the view controller as the system under test. We have to make a fake IB loader at this point because we're not going to use IB to do this. We're going to actually do it ourselves. The loader sets the views into the cell outlets, and this is what we repeat. We create a failing test. We implement the use case output method that we're interested in. So the use case output is the protocol. It'll usually have another name in front of it to identify whose protocol. We capture the behavior via the view properties or adapter mocks and stubs, which means that we're going to put the data into the views, and then we're going to test the views to make sure they got the data. Okay, so that's testing behavior, and then we verify pass. Okay. Okay, so let's look at so what we're going to do here, I'm going to ignore this for now because this is actually that simple case of the data coming in. So we're only going to look at this. So when you think about it, what is it that we're going to do? Okay, so what do we do to get the data into the table? Besides filling up all the cells, the last thing we want to do is actually make the we want to do a table view reload. Okay, reload data. So there's going to be one method on the output called show report. I'll get to all the rest of it in a minute. But the bottom line is that the only way I'm going to be able to test whether I've actually affected the table view, that is, that I've done something to it, is to actually figure out whether data is trying to be pulled from the adapter. Okay, so think about it. So if I want to get inside and test the behavior of the table view, I need the table view to do something. And in this case, what it's going to do is try and grab data. Okay, so you start to understand funny things you didn't normally think about when you start doing test-driven development. So this is how I'm going to do it. I'm going to actually create a data source, and it's going to be a stub. So this is how I set up the test. We're going to go here for a minute. And I've got this stub, and I have to implement all of these functions. And what I'm going to do is find out if the adapter is getting called, because the first thing it's going to do is call that. That's how I know that show will try to reload the table. It's pretty long-winded, but that's how I know. Now, you may want to know what's happening here, because I've got this I'm making it be off. So one thing I forgot to mention, the transaction list adapter is actually created automatically as part of that templating that we did before. So right now, the transaction list adapter has nothing in it. But I'm inheriting off of it, and I've also told it that the transaction list adapter implements the data sources and the delegate. And you can see here that I've got overrides, but that actually came in later because until I actually start implementing the transaction list adapter, I don't need to override because it doesn't have any of this. Okay, but ultimately, when I finally get to some of the other tests, this test failed because I have to turn it into an override. Okay, so this tells me that the adapter was called, and this is how I'm loading it up, and you can figure out what that means. Okay, and now I have to create a function. You get to see the function is pretty trivial. You're going to go, that's a whole lot of code for a trivial function. it is. Right, we talked about it. That's what I knew I was going to write. And that's how I get my table to reload. And now you also know how I test it. And it's really trivial. Now, I guess I should talk about this while I'm at it. This connector, okay, is basically how I configure this came out at the beginning. This was generated. And that was created in order to tie the view controller and the presenter and the use case together, and it gets called in awake from nib at the beginning when it gets pulled out of the story. So that gets done as well, but you don't even have to think about that because it's part of the template. Okay, so now the next step is to go on to deal with the cells. Okay, and the cell tests are the same as everything else. This is going to get pretty mundane. It actually feels better to do than it is to listen. I'm telling you. And it's worth it. I'm laughing at it, but I know what it looks like. So anyway, we're populating all the cells. You repeat this stuff. To create a failing test, you instantiate a cell. You set the views into the cell outlets. And sorry, just to mention, there would be other when we say show on the last one, it could have actually had some data in it, and you could have been setting that data to other views. So that would have been one of the things you would have done there. But now we're doing exactly the same thing for the cells. Okay? So basically we set the views into the cell outlets. So actually I said this before, there's this cell protocol that we're going to talk about in a minute. We're going to make sure it implements its own show method. We call the show method on the cell. We get the set values to compare them and verify. So we're literally doing almost the same thing as we would have done for the view controller, because the cells are like little view controllers. Okay, so these are all the cells. And here's the cell tests. What direction? Okay, so if we take a look at the first one, we want to make sure, okay, so there's this function called show. There's a little bit of stuff that I already understand in my head about the way this is going to work. Basically what's happening, and this has nothing to do with Viper, it just has to have to do with good style, is that in get cell for row at index path or whatever, basically there's a mapping between data and a cell. You've seen it a million times. But a good form is to basically have a function on the cell called show. And that function maps the data into the cell. And it does, and basically that function is part of a protocol, and every cell responds to that protocol. And that way, you don't have a bunch of cases in your cell for row of index path. It's simply object-oriented. So that's sort of what we're going for. So basically, all I need to do is I grab a cell. I set the label into the cell because that's what it is. It's got a title label, and then I call cell.show, and we're going to get into this in a minute. What this is, there's a data set that we're going to talk about in a minute. That I created, and then I grab the value out of it, and I check to see if it's true. So, and I do that for every single cell. So let's take a look for a minute at some of these protocols. Okay, the first one you'll want to see is this. So basically, every single cell ends up having this protocol. And it basically takes a transaction-less view model. Now, don't be confused. These view models are not the same view models as MVVM. These are simply models that are perfect for views. Some people think that those are the same, but I don't think they are. I'm not an expert in MVVM. There's an extension on this. We'll talk about it later. But basically, cell for row at index path is going to call that function on every single cell, whenever it gets a cell. Okay, and what does that look like? The next step, so let's tie that together. I want to show you the view models. That's a test case, sorry. So these are my view models. This is what I'm ultimately going to generate. What I'm doing, I've already decided that's how I'm doing my view models. So there's a lot of preconceived and well understood stuff behind this about how I'm going to put this whole thing together. So I guess part of the point here is that you kind of got to know what you're doing beforehand, plan the thing out as you would normally, and then start writing your tests to make it happen. Okay? So in this case, I've got a transactionless view model. It's a header, and it's got a string. So all I'm trying to do is take the string out of there. That's all I'm trying to do, and stick it in a cell. And I've got a test for that. And I'm actually building this up at the same time. So basically, I know in the test, so let's go back to the test for a minute. It's a little hard to do this. Sorry. No, it's really complicated. I can't see this out there.
Are you looking for a specific file?
Yeah.
You can do, oh, you got it? Okay.
Okay, so here, what did I already know? I already know that I've got my header cell, so I have to create that. I know that I've got to deal with something that's going to hold my data, and so I go and I create that. In order to make this test pass, I had to create that, I had to create that, and then I did the test. So those are the two tiny little things that I'm doing. Except that this was already known. We already created this when we did the IB test. So we already have that, and I just created that. And that's all I really did here, was create that. Each one of these tests creates another one of these, because they were already, all the cells are already created. Okay? So basically you can imagine that I've got a ton of tests all doing exactly the same thing. Okay? So far I don't even know how I'm going to generate this report. I have an idea how I'm going to do it, but I do know what rows I know what they're going to look like. I know what the spec looks like because somebody drew me a picture. Okay, so I know what every single line looks like. So all I'm doing at this point is making a place to capture that data and then putting it into a cell. That's all I'm doing at this point. All right, so you can sort of see the direction and rhythm that we're headed for. Okay. So the next thing is the presenter. Okay, so what does the presenter do? It takes data and it does one of two things. If it's not the cells type data, if it's simply if it's data that's going into views, then there's a protocol for that, and basically we do the same thing. So all we're doing in this thing is we're going to call show from present, and that's all we're going to do. Because at this point, the only job that the presenter has to do to get that view on the screen is to call show. So basically, you have present report, and it calls show, and that's what the test is going to do. The more interesting stuff happens with with the view model test. And I'm going to go there because I know people are going to fall asleep. Okay, so how do I make those view models? Okay, basically, it's instantiated by the presenter. We create the failing test by calling some method called present something. We implement it. It's part of the use case output. And we basically have to figure out whether the values are set in the view models. So this is becoming really simple. So all we have to do is test that the view models got the data that we think they're getting. These tests look almost identical to the show tests. The only difference here is that we're creating view models and they're actually not being put anywhere at this point. Because what's happening is we're actually going to collect all these view models inside the presenter, and then we're going to use the table view to access the view models. So you end up with the adapter trying to access the view models. So I can show you what that looks like. That's the view model, sorry. Okay, so this is going to look identical. I'm going to have a lot of tests where I go present header. In this case, I have authorized or posted, and now I have to implement something new. So not only do I have to implement present header, but I've got to implement something to access those rows. And actually our SCT in this case is the presenter, because we're not actually pushing the rows all the way to the view yet, because it's the table view that needs to get the views. So we have to have a place to put them. Okay, so basically I've made that the domain of the presenter. So the adapter connects to the presenter, and he holds the views. Okay, so basically what we're doing is grabbing a row out of this row access, checking that it has what we want, and then making sure we get the right one, and then we assert that it's what we think it's going to be. Okay, and if we talked about this before, if we want to find out, if there's localization issues, they actually are handled in the presenter, and this would probably be some kind of token if we're dealing with localization. So let's look at how we implemented that. And this is what we're testing. So we're testing the presenter. And at this point, we implemented these two functions, actually. This one, and actually, I don't even know if we've implemented that. Because in the test, we know we put it at the first position. So we don't have to implement this yet. But we did have to implement this to make the test pass, and we had to implement this one, present header. So basically, you can see how I still don't know how I'm going to write the report yet, which is kind of interesting. But I do know how I'm going to store the data, and I know how I'm going to put it out to the output. And that's the direction we're going in. Okay, so now we're going to get to the more interesting part. Then I'm probably going to let you guys go. I was going to talk about the table adapter, but I'm going to let that go. You guys can take a look at this code when you're done to see how that was done. What I'm going to do is show the transformer, because actually that's the most interesting part of this whole thing. As I said, this is where it all happens. The way the transformer is set up, it actually allows you to test a pure algorithm with no conversions. And that's super freeing, because you don't have to bother yourself. Once you've done this technique, you don't have any more code that looks like an int value, like you have some value x and you also have some value string x. You don't have any of that. You never see that in this kind of code, because everything is converted beforehand into its primitive type, and everything is converted out through the presenters. So you don't have any of that. You're just dealing with pure code and pure values, which is really kind of nice. So where are we at? We instantiate a transformer as the SCT. We create Okay, so we create fake models to stand in for output. You're going to see this in a minute. We're implementing the use case output with fake models. Basically, we have to create data sets. This is where we get to test all of the different kinds of things that can happen to our input. So we can have we can't get input. We can have input from one processor, not another. We can have no records from one processor and records from another. We can have records from all of the processors. And all of that can be tested right here as tests. That's where we go. So, first I'm going to show you there's some magic going on. Okay, and this is what TDD is not going to buy you, and where you actually have to write some code, or actually use your noggin. Second. Okay, so these are the tests. Okay, so there's two kinds of algorithms that I put together here. I'm going to concentrate on the two-source type. You can see here, now don't forget, I've already tested that I can convert, that I can create, I've already tested that I can create view models, and so I know that anytime I call these present routines, they're going to do what I want them to do. So in this case, all I'm doing is exercising the algorithm. I'm not exercising any of my conversions. So what we're doing here, I've created a test. I've got two sources, authorized none, posted none. So basically, I'm going to create a test where in my transformer, I've got no transactions, 0. That's the test I'm going to do. Okay, and then what I want to do is compare to some output. Now that output is interesting because that output, I'm going to have to look for it on the page, that's a problem. Authorized, not found, posted. So here I have a whole bunch of data. This is the data I'm setting up for my tests. Okay, so you see I've got 2 streams of posted data with all of the stuff I need. And now I'm going to go find my output. Okay, so what I'm doing is I'm actually going to create a new set of view models. And what I'm hoping is that every time I do a present, it's going to create a view model that's really simple and doesn't care about the data. Because I already know I can deal with the data. So now I'm just testing sequencing to make sure that it's doing the sequences that I want it to do. Okay, so now I create a new view model, which is a dummy, or fake, or whatever you want to call it. And then I'm going to go look at the data. Okay, and so what I've got here, okay, so here's my output for authorized none, posted none output. So what it is, okay, so what is this FTLVM? It's this. Blah, blah, blah. A really long name. Okay? So, for this output, I want to see a header, a not found message, a header and a not found message, plus this tail output of grand footer and end of report. That's what I want this thing to produce. Okay? In another case, authorized none, posted none, I want to see this. Okay? In the case of all not found, and that's for different sequencing, I want to have a not found message. In another case I want authorized output, there's another test where I want all output to be authorized output plus posted output plus the tail output. So I'm basically trying to generate this. So what I'm saying is that the input data must generate this. So now you can see I've got a complete handle on this thing I've got to do, which is generate this report. I've completely isolated. And that's part of your answer. It's the isolation that's important. And it's really good whether you're doing, now this transformer is not actually part of Viper. It's something that I actually did even before I met Viper. I just thought it would be a good idea. And all of a sudden it fit right in, which was really good. So, what you need to see now is the actual algorithm. Sorry. And that's in the use case two-source transformer. So you can see actually the input to the transformer is these transactions. I tell it to transform it, and I put it out on this output protocol. Okay, and here you can see, as I was talking about before, I've got a reusable function because I've got two identical streams. And even in real life, maybe the streams wouldn't have come in identically, but they've got exactly the same data. So they actually work through the protocol as well. So it wouldn't really matter. But what's going on here is I initialize it. That way, if I'm going to run this more than once, I'm going to clear my output. And do those kind of things in there. So what do I do in here? I'm working with this group. I check to see, so here's where we put out a no transactions message. Here I convert it to a stream. That's a whole other story. I could spend a day on that kind of stuff. And here I go eating up the transactions and grouping them together, presenting the subheader. So what I'm doing is grouping dates. So I basically put out the current date. I eat up all the ones on the same date. I output the detail for each one of them. Then I present the subfooter, and it turns out the subfooter is just a piece of leading in this case. And then I present the footer, and then in my other case, present what I found. So the bottom line is, I actually don't have to test for what I'm putting out. All I'm testing is the sequencing. Yes.
Sorry, we're just running a bit.
Yeah.
If this is not online, can you maybe point people to
Yes.
afterwards? Let's check this slide.
Yes, and I was going to close right now because I'm done. It's hot in here. Okay. So yeah, this is posted online actually, and I can send out the slides. Any questions?
I have one quick one about like the Viper in general, I guess. Initially, I thought that the router is like a coordinator. Are you aware of like the coordinator pattern?
No. Tell me.
It's you can read Serge Hanlo has written an article about it. It basically replaces storyboard. So the coordinator does like all the coordination of like use controllers and navigation controllers and stuff. And that's what I thought the router is, because there are different names for that. I guess, can you explain what is the purpose of the router in the Viper pattern?
So it sounds like it has a similar purpose. And essentially the router is the guy who knows how to switch between viewports.
But isn't it the storyboard's job?
Well, see, I have something to say about this. Apple has tried to make it really easy for us to switch between viewports. And in so doing, they have caused us to put a whole mess of code into our view controllers. From a proper OO outlook, that is not the job of the view controller. It's actually the job of the container of the view controller, who happens to be a view controller. It could be a nav controller, it could be a tab bar controller, it could be a custom controller. If you look at how Android's put together, that's exactly what goes on. And another problem that's caused by doing it the way that we've been taught to do it is that we can't reuse our view controllers in other contexts. So by moving the burden, so basically anytime you access a method on a navigation controller from your view controller, that piece of work should be done in the view controller. And we're being fooled by segues because it's actually using that, because it knows about it.
So you're using storyboards but not using segues?
That is not correct. I love segues. And I wouldn't want to get rid of them because they have great documentation, great for documentation and all that kind of thing. So what I've done in one case where I actually implemented it wrong, and Annelin's been here with me, is that I actually did some wiring to make it happen so that the router knew who was to do the navigation pushing. But in another version that I'm going to do, I would say that all of those functions should be done by the container, by your parent.
But there are people who do Viper and strictly avoid segues.
Yes.
Yeah.
Similar to how Suresh, when he describes coordinators, I think he's very final about not using segues. And he has the router in Viper is fairly analogous to the coordinator. I think Suresh just proposed a couple things like in a tab view controller, you'd have like multiple coordinators for each tab, but you'd also have an overall coordinator. In Viper, you could come up with a modified Viper where the router is actually there's one router and there's a bunch of Vipes, if you will, hanging around. But that's like a modified version. But it is for the most part analogous to the idea of coordinators. It's just the other stuff. The Vipe part is different from say MVVM, right? So it's like if you took MVVM and coordinators and put them together, and then modified MVVM to be a little different, you'd have Vipe.
Okay, I guess
That's how I think of it.
Yeah. I guess I also have like a very short question. MVVM, you can implement the architecture like parts of the code that you feel that you need to. Is it the same with Viper, or is it like the architecture for like all?
Yeah, but well, you could certainly make view controllers any old way you want, and because they just work like regular view controllers, they just fit in the case. So you're not forced to do it in every single situation. But if you start doing the routing the way that I just talked about it, you probably will have some trouble because you're going away from their normal pattern.
I think something to remember is all of these different methodologies are a framework to guide your thinking for how to architect your app. At the end of the day, you don't have to use a name for any of these things as long as you properly separate your concerns and encapsulate your data. You can kind of do it however you want, right? And these are all just methods to help people get to that end state.
All right, so I hope you guys enjoyed and see how the two fit together. That was the main reason. I know it was a bit long-winded, but seeing how TDD, the two takeaways are that Viper provides access into your code, and the other takeaway is that you actually have to write code normally. You have to be thinking about that code normally. There's no magic, except for the fact that it'll help you write better code. That's a whole other story.